Hey everyone, and welcome to The Explainer. Today, we are undertaking what I like to call a very high-stakes digital autopsy. We're going to pull back the curtain and look deep inside the actual physical mechanics of the legal documents and digital contracts that we interact with every single day. We often just blindly trust that what we see on our screens is this perfect, binding representation of the law. But the truth hidden way down there in the silicon, well, it's a lot more complicated. And honestly, it is absolutely fascinating.
Okay, let's dive into this. Our descent into the machine today is going to cover 1. The DOCX semantic gap, 2. Weaponized semantic indeterminacy, 3. The patent thicket crisis, 4. Engineering deterministic law, 5. Forging the semiotic bridge, and finally, 6. Stewards of the machine.
All right, starting off with Section 1, the DOCX semantic gap. So I'm about to shatter your reality just a little bit when it comes to how computers actually read text. Think about those complex digital contracts you read on your screen. Are our digital laws just a clever illusion? We really need to establish a fundamental premise right off the bat here. What you and I see beautifully formatted on a computer monitor is absolutely 100% not what the machine understands. To really grasp why this happens, we have to look at the collision of two completely different universes. First up, there's what experts call wet code. This is our traditional human law. It's inherently ambiguous, it's highly relational, and quite frankly, it's forgiving. Mostly because, well, we humans are forgiving. We bend the rules when the context demands it. But in stark contrast, we have dry code. This is the language of machines. It operates strictly on cold, unforgiving binary logic. It is completely deterministic. It literally doesn't care if you had a bad day, it just executes exactly as written. No exceptions. And that massive collision leads us directly to the murder weapon of our autopsy today, the DOCX semantic gap. This is essentially the total failure of standard visual word processors to actually translate our structural human intent into mathematically verifiable, machine-readable data. Basically, when you draft a complex rule in a standard DOCX file, you're essentially just visually painting a picture of a house. You are definitely not creating the actual structural architectural blueprint. And that lack of a true blueprint is exactly why visual formatting completely fails us. When you use bolding or numbered indentations, it gives you, the human reading it, this totally false and honestly dangerous illusion of legal structure. But deep down inside the hardware, the computer's processor is completely blind to your visual styling. Without an underlying layer of structural code, like XML, to tell the machine what that text fundamentally is, that bolded paragraph you just spent hours perfectly formatting is just a random, meaningless string of letters to the computer. Which brings us to Section 2, weaponized semantic indetermination. Now, you might be thinking this structural gap is just an accident of early software design, but actually, it's deliberately exploited. And the frustration over incredibly dense, purposefully vague legal text, it isn't a new problem at all. Just look at this incredible quote from the famous judge Learned Hand, way back in 1916. He said, "It takes the scholastic ingenuity of a St. Thomas with the patience of a yogi to decipher their meaning." This deliberate manipulation of language has literally plagued the justice system for over a century. Fast forward to today, and elite patent ghostwriters weaponize this exact linguistic ambiguity to build massive corporate monopolies. Instead of simply saying two gears in an invention description, a patent agent will intentionally write plurality of gears. They love deploying fuzzy modifiers like substantially contiguous. It's this incredibly calculated tightrope walk. They're actively engineering the text to appear extremely narrow and specific so it safely passes the human patent examiner, while simultaneously acting as this broad, hitting trap to capture any future competitors. And the result of that? Section 3, the patent thicket crisis. 250,000. Just let that staggering number sink in for a second. That is the estimated amount of active, overlapping patents sitting on a single modern smartphone, one phone. It creates this wildly hostile patent thicket that makes navigating new innovation almost entirely impossible. And the crazy part? A huge portion of that thicket is built on purpose. Experts actually estimate that 25% of patent text is deliberate patent clutter. This is non-inventive, filler verbiage deployed specifically to jam search engines and intentionally confuse human examiners. By stuffing their claims with this clutter, massive corporations create the illusion of a highly crowded technological landscape. This effectively locks out independent innovators from even trying. And it leaves us humans to act as moral crumple zones, just absorbing the legal damage when the whole system inevitably fails. So, how do we fix this mess? Section 4, Engineering Deterministic Law. To sort out this chaos, we have to pivot away from these messy, probabilistic failures and look toward incredible engineering solutions designed to force exact mathematical truth into our legal systems. First, we've got to look at the hardware actually making the decisions. On one hand, we have the FPU Gambler, a floating point unit that relies on probabilistic guessing. It actually destroys data provenance and wipes out the chain of title entirely. We absolutely cannot use a gambler for the law. Instead, we need the ALU surveyor. The arithmetic logic unit performs exact, verifiable math. We're talking flawless hardware determinism here. 1 + 1 is exactly 2 every single time, no exceptions. And to actually leverage that exact deterministic hardware in the legal realm, we rely on something called a komantoso, or legal doc ML. This is the foundational fix we've been looking for. It's a global standard that completely replaces standard visual word processing with highly structured, actionable, and machine-readable XML. It literally turns dead ink on a page into living, executable data. This means the computer can finally read and enforce the rules, using unique identifiers to give our laws a permanent, unbroken digital memory. So how do we actually build this into a functional reality if XML is so impossibly strict for regular people to write? Enter the BDOM synchronization pattern. Let's walk through this. Step 1. A lawmaker just types naturally in a visual editor, using their normal human thinking. Step 2. An invisible extension silently encodes those edits as precise mathematical coordinates. Step 3. The system instantly rewrites the rigid XML in the background. It is a completely brilliant architecture. Humans get to act like humans while seamlessly feeding the machine the unbroken math it craves. Let's move to Section 5, Forging the Semiotic Bridge. This beautiful synchronization pattern we just talked about leads us directly to the concept of the semiotic bridge itself. This is strictly formatted text and code acting as a universal, deterministic interface. It is literally the one and only way we can safely compile our boundless, messy human imagination directly into physical hardware execution. I mean, think about it. You can visualize it as literally using text to trick rocks into thinking using lightning. How cool is that? Just look at the profound and frankly terrifying gap we are crossing here. On the left side, we have OS alpha, our human cognition. It flows continuously, it's warm, associative, and wonderfully messy. On the right side, we have the machine. The ALU is cold, rigid, discrete, and demands absolute, unapologetic exactness. The semiotic bridge of structured text is the absolute vital link, the only link, that safely connects these two entirely alien worlds. And that brings us to our final stop, Section 6, Stewards of the Machine. Look, as we rush headfirst into this new age of algorithmic governance, we absolutely must keep the human in the loop. Algorithmic code, no matter how good it gets, will always crash into unpredictable, weird human nuances. The simple, automated vending machine style of smart contracts cannot possibly handle deep, nuanced concepts like substantive justice or morality. Because of this, the system desperately requires the sweat of the brow from a human pilot to actively orchestrate the truth. We need human grace and manual structural intent to actively bend that cold code toward a moral mandate. We simply cannot surrender interpretation entirely to automation. So, I want to leave you with this final provocative thought to really ponder as we wrap up today's explainer. If we actually go ahead and completely surrender text interpretation and the authoring of the semiotic bridge to automation, who ultimately controls the physics of our reality? Will you step up to actively wield the deterministic rules of the future, or will you just surrender control to the probabilistic machine? Think about that the very next time you look at a digital contract. Thank you so much for joining me to explore this incredibly complex topic today, and as always, keep learning.